problems based on nth term of geometric progression. So here geometric progression symbolically or in abbreviation can be written as GP. So we are going to discuss, we are going to perform few problems based upon nth term, problems based on nth term of the geometric progression under part 2 in an advanced level. So here the nth term of the geometric progression is given by means of Tn is equals to a r to the power of n minus 1, whereas r is the common ratio and is the first term. Then now let us perform the problem under part 2. The fifth, eighth and 11th term, the fifth, eighth and 11th terms of geometric progression are P, Q and R respectively. So here as per the problem, the fifth term will be of P, eighth term will be of Q and 11th term will be of R. Then we have to prove, then show that Q square is equals to PR. So we have to prove Q square is equal to PR. Solution starts now. So in our solution, as per the problem, fifth term, eighth term and 11th terms are P, Q and R of a geometric progression. So now when we write individually, the fifth term will be of P and the eighth term will be of Q and 11th term will be of R respectively. Then we have fifth term, which is denoted by means of T5 is of P, eighth term which is of T8 is of Q and 11th term which is of T11 is equals to R. But we know that the general term, that is the nth term of the geometric progression, is given by means of, so Tn, the nth term, is equals to a r to the power of n minus 1, in which a stands for the first term and the r is the common ratio. So here in which a is equals to T1, which is nothing but the first term, and whereas r is equals to common ratio. But the first problem, it is of, the first condition is of fifth term, that is T5 equals to P, and the second one is of T8 is equals to Q, and the third one, the condition is of T11 is equals to R. So here we are going to perform the first one. So here first one is of T5. So here T5 is equals to P. By comparing now, so here Tn is equals to, we are comparing this T5 is equals to P with this gen term. So here general term, that is Tn is equals to r to the power of n minus 1. So here n, when we substitute it as 5 at n is equals to 5, then now, so when n is replaced by means of 5, then the right hand side will be of a r to the power of n minus 1. So we can write it as a r to the power of n, n is of 5, that is 5 minus 1 is equals to P. So that implies a r to the power of 5 minus 1 is of 4. So your nth term is of a r to the power of n minus 1, 1 less than this nth term. So here T5, the fifth term will be of a r to the power of 1 less than this condition, that is 5 minus 1. So a r to the power of 4 equals to p. So in this manner we got the first equation as a r to the power of 4 equals to p is the first equation. Then now let us compare the second condition, that is T8 equals to q, with this gen term, that is Tn equals to a r to the power of n minus 1. Then now, so here the nth term Tn is equals to a r to the power of n minus 1 is the general term. Now here, but T8, the eighth term is of q, but the eighth term is of q. So here as per the eighth term is of q, so here now we are going to replace n by means of 8 at n is equals to 8. Then we have, when n is replaced by means of 8 in this condition, so a r to the power of n replaced by means of 8, that is 8 minus 1, in order to get the eighth term. So here n is replaced by means of this 8, so here a r to the power of n replaced by means of 8 minus 1, then that is equals to q. So that implies a r to the power of 8 minus 1 is of 7, that is equals to q. So this is our second equation. Then now the nth term, the condition, that is the general term, is of a r to the power of n minus 1. So as per the problem, the 11th term, so T11 is of r. Then now, so T11, so here when n is replaced by means of 11, so we will be getting the 11th term, so which is equals to, so at n is equals to 11, so equals to a r to the power of n minus 1, so n replaced by means of 11 minus 1, so that implies a r to the power of, but 11th term, so as per this question I say here 11th term is of r, so we can write the 11th term which is equals to r. So here a r to the power of 11 minus 1 is of 10, so which is equals to r, so we can write a r to the power of 10 equals to r is the third equation. So from, I am going to divide second equation by means of the first equation, from 2 divided by 1 equations, then that implies second equation is of, so here second equation is of a r to the power of 7 equals to q, a r to the power of 7 is equals to q. We have to divide second equation by means of the first equation, but the first equation is of a r to the power of 4 equals to p, the first equation, a r to the power of 4 equals to p. So divided by a r to the power of 4 equals to p, so we have to divide the right hand side by means of p. Then now, so we can cancel the like terms, that is a and a will be gets cancelled. Then now r power 7 divided by r power 4 equals to q by p is the next logical step. Then now r power 7 divided by r power 4, so that implies r power 7 overall divided by r power 4 is equals to q divided by p, but it is in the form of a power m divided by a power n, the bases are equal here, but numerator's exponent is greater than the denominator's exponent, so I am going to use this identity, that is a power m overall divided by a power n is equals to a power m minus n, whereas here m is greater than n, whereas when m is greater than n we can use this identity. Based upon this identity, so I am going to write this logical step as, so that implies r power 7 divided by r power 4 can be written as, so a power n minus n, that is m minus n, so here bases are equal, so it can be written as r to the power of 7 minus 4 in the numerator, so that equals to q by p must be written as it is. Then now the next logical step as r to the power of 7 minus 4 equals to 3 is equals to q divided by p. Let us write this condition, r to the power of 3 is equals to q by p, as the fourth equation. So in the previous step I have divided second equation by first equation, then now I am going to divide the third equation by means of the first equation, second equation, 3 divided by 2. From 3 divided by 2, third equation divided by second equations, we get the third equation is of third equation is of AR to the power of 10 is equals to R. So that implies AR to the power of 10 equals to R. Then divide by second equation. The second equation is of AR to the power of 7 equals to Q. Overall divided by AR to the power of 7 is equals to Q. So right hand side must be divided by means of Q. Then now, so here like terms A and A will be gets cancelled because there are of into in between A and as well as R power 10 in the numerator and A and R to the power of 7 in the denominator. So A gets cancelled and only R to the power of 10 divided by R to the power of 7 is left over on the left hand side equals to R by Q on the right hand side. The next logical step will be of R power 10 divided by R power 7 equals to R by Q. So that implies R power 10 overall divided by R power 7 is equals to R divided by Q. Now the left hand side R power 10 divided by R power 7 is in the form of A power m divided by A power n. So here A power m overall divided by A power n can be written as A power m minus n when m is greater, when this m is greater than n. So here this is applicable. So here based upon this identity we can write it as. So here as per the problem left hand side essay is of numerator's exponent is greater than denominator's exponent as per this rule. So we can write it as. So that implies R power m minus n. So here 10 minus 7 is equals to R divided by Q. That implies R to the power of 10 minus 7 is of 3, that is equals to R divided by Q. Then now R to the power of 3 equals to R by Q is our fifth equation. Now from 4 and 5 equations, but the fourth equation is of R cube is equals to Q by P. R cube equals to Q divided by P, which is the fourth equation, and fifth equation is of R cube is equals to R by Q. So here when we observe these two equations, the left hand sides, say R cube and R cube, left hand sides are equal. Since left hand sides are equal, hence the right hand sides must be equated. So here we can write it as, so Q by P must be equated to R by Q. Since left hand sides are equal, hence right hand sides must be equated. So in order to equate the right hand sides, so we have to write R by Q, Q by P equals to R by Q. So here Q by P equals to R by Q. So Q by P equals to R by Q. So now, so since there is a equality symbol, so now by cross multiplying, so Q must be multiplied with Q. So here the next logical step will be of, so Q into Q, Q dot Q equals to P into R, so P dot R. So that implies, so Q into Q is of Q square, that is equals to P into R is of PR. So here hence it is proved. So here we have to prove Q square equals to PR. So as per the problem, so here we have to prove, show that Q square equals to PR. So in this manner, when 5th term, 8th term and 11th term are given as P, Q, R respectively, so we have proved the condition, that is Q square equals to PR.